Welcome to a new CADSIM Plus tutorial. My name is Renaud Denzer, and I'm going to try a little something new here where we're going to cover a couple of things today in a more casual fashion. So here I am selecting a non-process text where I'm going to type out our learning objectives for this tutorial. I could click OK right here or hit the Enter key to start a new line where I'm going to type in using signal logic, which is the first thing I want to discuss. Subsequently, I want to cover connecting to Excel using COMCLIENT. And our third objective will be to introduce you to a process module called Permutations that is useful for doing sensitivity analysis. So let's zoom in on this a little bit here. Throughout this tutorial, I'll kind of mention a couple of things that could be useful, tips and tricks, and so forth. So today's example is going to be a non-engineering related example. I want to answer the question, how fast will you bike? I've been doing a little bit of research on gear ratios because I'm an avid cyclist. So are we all here at Orel. And so I thought that would be a good way to introduce some concepts using signal logic. So here we have a big chain ring. There's a little chain ring here, or a cog, a rear cog really. And let's add another one. I'm drawing these with non-process circles. For fun, I'm going to add a little chain. It's going to have an arrow. That's okay. It's just a schematic. We'll add a little crank here too. Why not? A crank arm and a pedal, which means opposite of that should be the other. Crank arm and pedal. These are arrows. Let's remove them. So you can press and hold the Control key, select your non-process lines that you wish to edit. I'm going to add a 0 here to remove the arrowheads. And let's make it a little thicker here. Here's our preview of what it'll look like. Hit apply, select our non-process lines, and it edited them, except I forgot to highlight and select one of them. Let's see if that'll do it. I said I wanted to remove this guy and add a little thickness to it. Here we go. So that's my crank arm. As you're pedaling, you are propelling the bicycle forward. So there's a concept called your gear ratio, which takes your number of teeth on your large chain ring and divides it by the number of teeth on the small cogs, and that gear ratio multiplied by your wheel circumference will give you how many meters or how much travel you will have per rotation. So I thought it would be interesting to use signal logic to do this calculation. So I'm going to go ahead and click the graphics element attribute settings and select the signal logic line so that when I select a process line, it'll draw a signal line. So let's do that here. Let's do our first one here. And I said just moments ago, I wanted to divide the chain ring by the cogs. And so I want to use a part. Here I'm going to select signal math. I'm going to look for the divide module, which starts with D, divide. There it is. I'm going to insert that guy here, and it lands where my arrow was because that's where I left my anchor point beforehand. So I click OK. Let's highlight, or let's grab this process line, move it around a little bit. Let's give it some names. To do that, we'll click process text. So I'm going to select this first line and I'll call it chain ring. I'll say OK. I'll do the same for this guy here and call that guy the cog. And we should add a little format so we know what's going through this process line or signal line. So I'll create a new format. I'm going to have a round number, so I'm going to type in hashtag for a number. There's a drop-down menu here to select all your variables if it was a process line, but since it's a signal line, all we have to select the signal line, and I'll drop it here. Similarly, I'll do the same thing here. I'll select the line and place the format, and I can move stuff around a little bit to make it prettier. Maybe not spend too much time doing that. And out of that divide comes another line. Let's label it and call it gear ratio. Let's say OK. Let's also add a format on that guy, and we'll place it here. Now I am going to have some significant figures here and decimal points. So to edit this, I can click the format, click this hashtag here, add a decimal and 2 more numbers, so I'll get more significant figures. When I click OK, it's going to ask me if I want to apply this to all my formats. I choose to just do it for the selected one. Let's try and run this. It's probably going to ask me to save my new drawing. I'm going to say yes. Let's go save it. Typically, you want to save it in a folder in your CADSIM folder. I have here Renault examples. I have the bike gear ratio folder already prepared. And then we'll call it that one, bikes, speed. Why not? The first thing it asks me here is to specify what goes through this process line. If I click show me again, it'll highlight it. So I know I'm going to select the big chain ring. I think there are 53 teeth on that guy. And then I can select a number of teeth on my smaller chain ring, let's say 12 teeth. Sorry, smaller cog in the back there. And it's going to ask me to save. And when I click run over here, we'll get the gear ratio, which is 4.42. So that means every time I pedal one rotation, this thing spins 4.42 times. Okay, now we wanted to ask how fast will we bike, so we got to do some more multiplying here. We have to multiply that by the wheel circumference. So we're going to go and select multiply part. Let's put that one over here. Press OK. Let's make it a little taller. Select our default signal line, connect it to the multiplier, press and hold over here at the output of the multiplier, drag along, and drop another line. Let's give those some names here. This is a process text. Let's call this guy the wheel diameter, and we'll give that guy in meters. And I want to add another process text to this line here and call it the travel per rotation, which would be units in meters per, let's say, rotation, R. R might be confused with radius, but let's just say it's rotation. We can add some formats, always a good idea, so we can see when we are running a simulation what we get. Let's place one here. Unfortunately, the wheel diameter has more significant figures again, so let's edit this guy. Let's add 3 sig figs just for that guy. Select this guy, add a format, and I guess we would also want some additional significant figures, so now we'll pull it from the drop down menu. Click place, there we have it. We can move it around. Maybe make it a little bigger here, longer. And let's run, let's save. It's going to ask me to specify the diameter. Now I've done some research ahead of time, and the wheel diameter, I run a 700C bike with 25 millimeter thick tires, and supposedly that's 2 meters, 152. Let's run this guy. Here we go. That means for every rotation with the crank 360 degrees, we'll have a travel of 9.5 meters with a chain ring of 53 and a cog of 12 teeth, respectively. Now we're going to be multiplying this. So another multiplier block. Let's place it here, say OK. Make that guy a little bigger. Add a signal line here. We'll name it. We'll call it the cadence, because that is how fast you are pedaling. And that's the number of rotations per minute. Again, it's always nice to put in some formats. This should be a round number, so that's okay. Let's leave it at that. Let's not forget an output to our multiplier. Let's give it a name. It's like a label, really. Let's call it speed. And that'll be calculated in kilometers per hours. We could do miles per hour, but I'm more comfortable using kilometers per hour given that we're Canadians. And another format, 2 decimals for the speed. Let's place this guy up here. And I believe we also need to take care of our units here, because we have a travel per rotation, and we're looking at rotations per minute and then kilometers per hour. So kilometers, we have 1,000 meters per kilometer, and we'll have 60 minutes, per hour. That's it. So we need to do a little bit of a multiplication by a factor. So let's label this guy. We'll call it, let's say, 60 minutes per 1,000 meters, so that our units work out. So 60 divided by 1,000 is 0.06. Well, first it's asking us to specify our cadence, because we drew that one first. Typically, a cyclist will want to maintain something like 90 rotations per minute. And my direct setting here for the conversion factor would be 0.06, so 60 divided by 1,000. All right, this sets us up here for our signal logic calculating how fast we will cycle. Now, the beauty here is, say I drop down to the small chain ring, say 39, it automatically calculates that for me and tells me how fast I'd be going. Okay, that's great. We can do this all day long and change our stats and whatnot. Well, what if we wanted to print this out to Excel? That would be our second learning objective. So I got here an Excel sheet. I labeled it, or I named it or saved it as bike gears. And I'd like to publish these values to it. So how do we do that? Let's go back to draw mode. I'm going to be using the create COM data access wizard, which is over here in the menu. I'm going to pull down and drag a polygon name. Now you could easily just draw it here yourself and then do the naming, but this wizard kind of helps you along the way. So let's call this bike speed. You can see it automatically adds the COMCLIENT keyword here. It looks for COM compatible applications currently running, and it's identified my Excel file called by gears. And for us to be able to see something, I think I'm going to put a period of 1,000 minutes because the simulation runs quite fast. So it'll do something every 1,000 minutes. And so now it's time to select what kind of external variables we're going to send to Excel, which is the external, or internal variables to the external. So here we'll go to external means Excel. And the variable description, so this would be the cell that I want to publish this into. So I'm going to say cell A1 in my Excel file, and I'm going to add a plus plus, which means it's always going to add a new line after every 1,000 period of iteration. We can click the help files here to get some more descriptions. You know, here if you want to auto increment feature, that's where we use that plus plus. That's what I'm doing right there. More details are given in our help files. And so this first guy, I am going to be calling the chain ring. This guy is going to be my cell B1 plus plus. I want to call that guy the cog. C1 plus plus will be my gear ratio. D1 plus plus will be the travel. E1 plus plus will be the cadence. And F1 plus plus will print our speed to Excel. All right, I think I'm satisfied here. I'll click OK. And when I'll click run, it's going to ask me to specify these or link them. So let's do that. Let's click update. And here we are. It's going to ask me to specify the chain ring free variable. So I'm going to click the equate to another variable equation type, because I'm going to link this to this guy here. So let's place it. Now you can see when my specifications moves, I forgot to mention that earlier, if I hold down the Alt, it gives me more, it'll find me the snap. So right now I'm working on a hash map. Actually, pardon me, it's the control button. There you go. That's a full snap from here to here. So let's try to get it closer to where it says chain ring. It appears I probably need a quarter snap. So let's select a quarter snap. There we go. I actually click Control Alt to get to that quarter snap. And I'm going to add the term. So it's going to be a linear here to the chain ring, which is that signal here. So it's going to equate that guy. And let's repeat this exercise for all the other ones. So right now I'm hitting Control Alt to get these quarter snaps. So it's in line with the cog. This is the cog here. Let's click OK. Let's do this a little faster. Gear ratio, add term, gear ratio, finish. Moving on. We're looking for the travel, add term, travel. Okay. Cadence, add term over here, finish. And the last one, speed, is our solution here, finish. So if I hit play, I expect every 1,000 minutes of iteration, for them to print out for CADSIM to print out these variables in here. Let's try that. Let's press play. And that's what's happening right now in increments. If I were to change the cog to 15, we eventually should see it give me 15 instead of 12 over here. Okay, this is great. I could have not put the plus plus in, it would just keep publishing over the same cells, but I wanted to increment the lines because our next learning objective after doing this is to change these variables at every 1000 iterations, and that's where we're going to use the permutations module. So this is useful for conducting sensitivity analyses. So let's add a permutation module. To do this, I'm going to draw a polygon. I'm going to select draw polygon, and I'm going to click and drag across however big of a box I want. I think this will suffice here, and I'm going to call it permutations. And CADSIM is going to identify this guy as the permutations module. I want to add a couple of variables that I want to change. I want to change these two guys, the chain ring and the cog, as well as the cadence, so how fast you're biking. I'm going to select a process text here, and I'm going to use a unitcast keyword called chain ring equals 2 unitcast text type. Now what this is going to do, it's going to ask me to specify two values for chain rings. I'm going to do the same thing for the cogs and then the cadence as well. I'm going to have 8 cogs. Let's call this guy text type unitcast, and one more process text cadence equals, let's select 8 again, so how fast you're pedaling, 8 different speeds, and then we can space these out evenly. And if at any point we need more, well, let's just hit play. Let's see if CADSIM recognizes as the permutations module, and it did, because it's asking me to specify the trial duration. So I have to add this spec here, and I'm going to match it with what I have written out here, which is 1000 minutes. So it's going to change these values every 1000 minutes of iteration. And it didn't capture my chain ring equals 2. I believe I know why, because I didn't actually give the outputs names yet. So let's try this instead. Let's call the outputs, which I probably should have named before doing unitcast stuff, chain ring. This is a process text. Call that guy the cog, and call this output here the cadence. And while we're here, we might as well add a few formats. The cadence is also a big round number, and the cadence is also a big round number. Easy peasy. All you got to do is select format from the drop down menu, and then all right, a little bit of placing our names here, make it pretty. Let's see if it worked this time. Let's ask me to save. Here we go. It's asking me to specify chain ring first one, and I've got 2. All right, let's drop. Oh, I selected a single spec. Let's rather not do that. Let's re-choose, and instead of using a local specification, let's use the multi-spec, and it's direct setting, and then I can overlap it with the existing one, and it'll just keep them all in that one spot. So the big chain ring, I think it's 53. Typically on bikes, for your your typical racing bike, and I think the small chainring is 39 tooth. And then here we go for the cogs. Let's go from 11 all the way up to, well, the next 8 sizes. So we have 11, 12. Well, this is a very compact cassette. 13, 14. So you're definitely not going to go up a hill with this bike. What did I say? 14, 15, 16. Let's skip a couple here. Teeth is 16. Let's go 18. And the last one here, number 8. And let's go 20. The cadence. All right, cadence. We're looking at riding slow at 60 RPM. Let's add 5 RPM extra for every interval. So that's 70. Moving on. 75. 80. Oop, jump the gun here. 85. How many more do I got? This is number 7. So let's go 90, which is a good cadence, and a fast cadence. Let's go 95. All right. Let's save that. And if I hit play, because I added formats, I should see these change every 1,000 iterations or 1,000 minutes. And it keeps doing that. So it's 2 times 8 times 8. So that's 128 different combinations that we're going to push into our signal logic here, calculations, and publish these values to our Excel sheet, which was over here, which I think is still adding values. All right, let's pause. Let's stop the simulation. Let's Control Shift up, delete all of this stuff. And we're going to delete our specifications that we had placed here. And it's going to ask me to respecify them, and I'm going to link them with an equate to our permutation module. Okay, so signal, which one? Over here, chain ring, equate to another variable. So the chain ring, I'm going to do a Control Alt click on the snap. The cogs, same thing. Click OK, finish, and show the cadence. Same thing, equate to another, and here we go. And we click save. Now I suspect when I press play, it's going to start publishing all my stuff over here with these different combinations. So let's hit play. And indeed it does that. So we're going to get 128 different permutations. And of course it's sort of slow right now because I've opted to do it for every 1,000 minutes. We could do it faster really, but then we wouldn't have time to observe anything. And so we'll see here, we probably could have selected row A2, so it starts publishing these values starting this row, and then we could have named this row by the respective titles here, but I guess we know that these are the 2 big chain rings, the different cogs. This is our gear ratios, our travel, and of course if you have a long travel here, you have a high gear ratio, a high cadence, you'll get a high speed like 51 kilometers per hour. Or conversely, let's observe this guy, you're pedaling pretty slow, even at a high cadence, if you're using the small cog and the second biggest uh, cog that we have in the back. Let's see where we're at. I think we're almost there. Oh yeah, we've gone beyond 128. So let's pause or altogether return to draw mode. I know that we have too much data. It's probably repeating itself. So let's delete this, and we can select our data and go ahead and do some stuff with Excel, like let's sort them from largest to smallest. So unfortunately, it thought this was the title, but nonetheless, all the rest of the rows are ordered from smallest to largest. Or I can click undo, insert a line, give it this guy name, speed. Now this is turning into an Excel tutorial, but let's do this again. Let's go by speed from largest to smallest. Our fastest speed, no surprise here, at the fastest cadence, with the big chain ring and the smallest cog in the back. So I hope this was helpful. Here we've, to summarize, learned how to use signal logic, some divide, multipliers, how to name signal lines, how to format them, how to equate stuff to other variables. We've also covered how to add a COM client that'll communicate with Excel, from CADSIM to Excel, and vice versa. You can pull data from Excel into CADSIM. That'll be something we'll try in a different tutorial. And finally, we learned how to use the permutations module over here. All right, let me know, give me some feedback what you'd like to cover next time, and I'll do my best to provide you with some new CADSIM Plus insights. Thanks for sticking around, and see you next time.